Hello Year 8, today's lesson for Friday the 8th is on efficiency. Could you turn to a page in your books and complete the do now please? Pause the video here while you complete the questions. These questions were based on yesterday's lesson. If you have any queries about this, please just talk to me. I'll be on Teams. Here are the answers. Please make sure you mark the do now questions in your book. Pause the video here if you need to. The title for today's lesson is Efficiency and Dissipation. Make sure this is at the top of today's work and underlined. Today we will be learning about efficiency and its effects, and you will be calculating the efficiency of some machines and drawing and using something called a Sankey diagram. First of all, which of these two light bulbs do you think you would buy and why? And can you use this to work out what efficiency means? So, the light bulb on the left is an 80 watt bulb and that's its power, and it lasts 1,500 hours, but it only costs 50 pence. Whilst the light bulb on the right is more expensive at £2 each. It produces the same light as the other bulb, but only 20 watts, so it uses less power, and it lasts 12,000 hours before you need to buy a new one. Have a go at pausing the video and answering the 3 questions at the top using this information. So, personally, I would buy the light bulb on the right. Why? Because it lasts much longer than the light bulb on the left. And it's not that much more expensive. So, over time, I will spend less money. Also, it's only a 20 watt bulb rather than an 80 watt bulb, and that means it uses less electricity to light my room the same amount. So I'm not only going to save money buying the light bulbs, but I'm going to save money on my electricity too. Okay. Dissipation. In any activity, energy is always transferred to the thermal energy store of the surroundings. So whenever we do something, some of our energy is transferred to the thermal energy of the air around us, and this is called dissipation. And every energy transfer diagram should have some thermal energy store as an output, because it always happens. Most commonly, this is a wasted energy store. We don't really want to have energy transferred to the surroundings, but we can't help it. The energy store we would like to increase is known as the useful energy store, and the better an activity is at transferring the energy from the input to the useful store, the more efficient we say it is. For example, some people are much more efficient because they are better at transferring the chemical energy from their food to kinetic energy by moving. Efficiency. The efficiency of any device is the ratio of useful energy compared to the energy required to make the device work. And it can be calculated using this equation. Please make sure you have this equation written down in your books, along with a definition for efficiency. Pause the video here to get that done. So, I'm going to carry out an efficiency calculation for you. You're going to do this later, so make sure you're paying attention and watching carefully. So, as we all know, Miss Fisher loves household appliances, and as I told you, for Christmas, Father Christmas did indeed bring me a washing machine. So, that washing machine is supplied with 200 joules of electrical energy. 100 joules is transferred as sound and light along the radiation pathway. and 100 joules is useful energy used to wash my clothes. I'm going to take this equation that you wrote down on the last slide to work out its efficiency percentage. So I've done the useful output energy, which was my 100 as useful energy, divided by the 200 joules of energy that we supplied the washing machine, and then I will times it by 100 to get a percentage. So my washing machine is 50% efficient. Now it's your turn. Use a calculator to complete the table below. You're going to need to copy this into your books first. To calculate the efficiency of the following appliances, please make sure you show your working, like I did on the previous slide. I'm going to leave this here so you can pause the video and have a go. If you're stuck, for the first question, you need to do the useful energy, which is 90 joules, divided by the total energy, which is 100 joules. You're going to then times that by 100 to get your percentage efficiency. If you type that in your calculators, so 90 divided by 100 times by 100, you should get the answer to put in that box on the far right for the kettle. Continue this method for the television, the light bulb and the drill. The radio and the electric fan are an extension, as you will need to rearrange the formula to complete these. Here are the answers. How did you do? If you're stuck with how we got any of these answers, don't forget you can message me on Teams. Okay. Have a little think. In a minute you're going to pause the video, look at your table of results and answer these 3 questions in your head. What do you notice about the efficiency of each appliance? What do you think has happened to the missing input energy? And can you think a way of showing the missing energy? Pause the video here and have a think about these 3 questions. So, for the first question, none of the appliances had 100% efficiency. They were all less than 100. That missing energy has been transferred in a non-useful way. Maybe it was dissipated to the surroundings as heat, or by the radiative pathway as light or sound. We can use Sankey diagrams, which I'm going to show you on the next slide, to show this missing energy. Okay. These are the beginnings of some Sankey diagrams. So, have a think. We have our light bulb. What is the useful energy output? And what is the wasted energy? Pause the video and do the same for the drill. For the light bulb, the wasted energy is the thermal energy. Light bulbs can get really hot while they're being used. Useful energy is transferred as light to help us see. For the drill, there is energy transferred as heat, sound, but the useful energy ends up in the kinetic store. Okay, in your books, copy this and fill in the blanks. Here is our radio. You don't need to draw that, just write the words if it's easier, and have a go at filling in these blanks. Okay, let's fill in the blanks. Ooh. So, the input energy is going to be chemical energy. So we're going to transfer chemical energy by electrical work done. The useful energy. What do we want from our radio? We want energy to be transferred as sound. and this is going to have 20 joules, because this plus this plus this need to equal this. We're going to have some potentially some thermal energy wasted. Your radio might get hot. Energy diagrams can also be shown as Sankey diagrams. This is where we draw a picture to help us understand how much energy is transferred in a useful way and how much energy is transferred to waste. We could draw it like this, but the diagram at the bottom looks much easier to understand, that much more energy is transferred in a useful way through the light pathway, the radiation, than is transferred as heat to the thermal energy store. So Sankey diagrams are a more scientific way. You can do it on graph paper, however we will just be sketching them in our books today. So on the left we have our energy input, and the width represents that amount of energy. We put our useful energy to the right, and wasted or unwanted energy forms point down. In your books, have a go at drawing Sankey diagrams for the following appliances. If you can, make sure the width represents the amount of energy. So for radio, I might draw 10 centimetres wide. But if you can't, don't worry. Number 4 is an extension question. Please pause the video here and complete this work. That's it for today, Year 8. Please upload your Sankey diagrams to Teams for me to have a look at. Bye!